All right, Toby, we're live. If you want to
Hello,
intro us
hello.
in.
Thank you for being here for Ether Cosmology Reading Night. Tonight we are going to do a little bit of YouTube video watching and then a little bit of paper reading. As always, the disclaimer with these reading and research nights is that these are not planned entertainment nights. These are not planned presentation nights. These are live reading, live research, live question asking nights. And so, if you get bored with that type of a thing, feel free to tune out and come back and join us for one of our presentations on a Tuesday night or one of our other many events that we tend to put on. Thanks a lot.
All
Yeah,
right,
whenever
cool.
you
Thanks
want to
for
go
that.
ahead, Alan.
Yep, thanks for that intro, Toby. All right, so tonight we're going to be reading about spectroscopy. We're going to be following up on that. And we got a really good lead into the subject from Marie Robitaille, who has an excellent YouTube channel. Highly recommend. Links will be available here. And also, I made a custom playlist for those interested in spectroscopy and the sun and whatnot. You can check that out here. I'll get the links in a second. All right, so the links are here. Let's check these out. So anyway, we're going to watch about 10 minutes, 10, 15 minutes of this video to let him intro us into the subject, and then we're going to read a paper that he published on the subject and see if we can't learn what this man learned. So the idea here is he puts down some heavy critiques of the heliocentric model and how they say that the sun works. So that's what we're going to learn about. So take it away, Robitaille. Oh yeah, real quick. So I think the inspiration for this video was, I guess, him and Professor Dave got into a little online spat, and this is exactly how you handle an online spat, dude. You reply with straight facts, and that's it. So this is
Delusional narcissist, he
video
outlined some of
here.
the classic rants that he has become known for, straight that he is clueless. This, again, is reminiscent of clueless flat earthers. This idea is like an onion of stupidity that gets dumber with every layer you peel away. Coming from someone with zero experience in the field or even rudimentary comprehension of its principles is so mind-numbingly idiotic. We now have to downgrade Pierre's comprehension of basic scientific terminology from failing high school to failing middle school.
So we'll
This
kind of
idiotic
power through
analogy
the
he puts
preface
forward,
here.
this is a really common thing for con men to say. Honestly, it's that dumb. So they can push their idiotic agenda. Or just continue baselessly whining about scientific facts that discredit your stupid ideas. When everything you say is objectively wrong, try not to also be a narcissist about it. The desperation is palpable. Real scientists don't play pretend. This goes beyond while
a little, which is a good thing, disseminating science to people from all walks of life. Sky Scholar is a very different place for people who want to dive into the ocean of science rather than swim on the surface. So why even bother to reply? Well, he's got 1 million subscribers.
My bad. So he's like, yeah, he's got 1 million subs. People are going to check it out. So let's give him a landing page. So he makes this video to explain and rebut all the things that Dave put forward to critique his work. So he's like, defending
Negative
himself.
hydrogen
So
ion.
we're going to get into that.
So let's get started. An important note. The negative hydrogen ion becomes the key determinant of opacity at the level of the photosphere. This is a surprising model since negative hydrogen ions are extremely unstable and observed on Earth only in particle accelerators and in the upper atmosphere.
Really? That's funny because I use reducing agents like sodium borohydride all the time when I worked in a chemistry lab. They deliver hydride ions to reduce carbonyls on a substrate. Reagents like this are cheap and common. But Pierre isn't pretending to be an organic chemist, so we can let this one slide.
No, this example does not show sodium borohydride producing free hydride ions, and it is completely irrelevant to the discussion. The fact that a compound has the word hydride in its name does not mean that it produces the free hydride ion. There are lots of hydrides in chemistry, so who cares? In sodium borohydride, the hydride is contained in a molecule involving sodium, boron, and hydrogen. It is not free. It is also never free when it is transferred to another molecule. An intermediary transition complex is created, and bonds are simultaneously breaking and forming during the process. The free unbound hydride is never present. Now, Dave stated in his video that the sun is a gaseous plasma and that it is too hot for atomic hydrogen to exist. Like the astronomers, he wants the electrons completely stripped from the atom. Yet the same astronomers are proposing that the photosphere of the sun contains lots of free hydride. They need it to explain the solar spectrum. But in the free hydride, the hydrogen nucleus not only binds one electron, but now has to try to hold on to two. That is central to the stellar opacity problem, as you can learn in these classic papers and as I have reviewed here. Now, does that make any sense? What do you want exactly? A fully ionized plasma or a photosphere with conditions enabling lots of free hydride to exist? Astronomers should really make up their mind because these two ideas are diametrically opposed. In any case, the free hydride ion is an extremely unstable species, exactly like what I said. But where could we learn more about the free hydride ion? How about this sentence in the Astrophysical Journal? Although the detection of hydride in astrophysical environments remains elusive, a firm acceptance of its presence exists. That is astrophysics in a single sentence.
Yo, so to kind of recap what he's putting down here is their whole model is based on this hydride thing being present, and they've never seen it, dude. So they're just like, but whatever. So I seen your mic come off mute. Did you have something you want to add in?
I was just about to say how much I love this sentence, and you're right. It is the epitome of the science right there.
Yeah, so this is pretty devastating. Everything is built, well, not everything, but a large portion of it seems to be built on this, and it all hinges on this. So this is like extremely important here to understand what's going on here with this model right here, right? So what seems to have happened is Dave has conflated some common hydrogen boride, is that it, or whatever? That's not the same thing that's what they're talking about in the sky. And the thing that they're talking about in the sky is never remains elusive, right? But a firm acceptance of its presence exists. So, that's cool.
Absolutely.
So, and this is all related to how they, determine the chemistry of the sun and what's inside of the sun and the processes that there go in so that, we can have sunlight. So I think there's about 6 more minutes left, and then we're going to read that paper about the opacity problem.
No direct evidence required to enable a strong position. Let's move on. The sun is said to be unable to synthesize elements beyond the lightest, focusing only on the synthesis of helium. In this way, modern solar theory has crippled our sun because it can't make any of the heavy elements.
Nope. Stars the mass of our sun fuse helium nuclei together to produce carbon and oxygen through the triple alpha process, and heavier stars fuse all the way up to iron during their lifetime, then producing the heavier elements when they go supernova. We know this conclusively from spectral analysis. More Astronomy 101 information that is totally lost on Pierre.
No, Dave, you're advocating something which is completely false. The standard model of the sun focuses on the production of helium from hydrogen, exactly like what I said. I am correct. The astronomers have crippled our sun. They permit the pp reaction and the CNO cycle to produce helium, as described in this classic graduate text by Kippenham on stellar physics. Astronomers claim that the presence of heavier elements are just the remnant of some first-generation star that went supernova. These remnants were then pulled into the sun when it formed. The more simple and obvious explanation is that those elements are there because the sun synthesized them. Forget about the need for a first-generation star. Either way, the triple alpha...
Yeah, dude, the model's so backwards. They have it set up where, our sun doesn't produce the heavy elements, like he was saying, and that they're saying that there was like another generation of stars that exploded, and then like the remnants of that just happens to be in the gaseous mixturous cloud that ended up forming our sun. Right? So it can be smaller and still have some of those, but not like, dude, like how crazy is that? Like this is all just like interpreted off of, um, those spectral readings that they, are just trying to apply to a light in the sky. So I think
That's crazy.
I think that's about it there. I think that's about it. So yeah, we'll get to the paper now and read. One second. Pull this up. All right, here we go. So this is the stellar opacity, the Achilles heel of the gaseous sun. Second. Paris, man, I always say it wrong when it's the first word.
It's Pierre.
Pierre. Jeez, I keep anyway. Pierre Marie Robitaille. Thank you, Stone. The standard gaseous model of the sun is grounded on the concept of local thermal equilibrium. Given this condition, Arthur Millen postulated that Kirchhoff's law could be applied within the deep solar interior, and that of a black body spectrum could be generated in this region, based solely on the equilibrium arguments. Varying internal solar opacity then ensured that a black body spectrum could be emitted at the photosphere. In this work, it is demonstrated that the local thermal equilibrium of the solar opacity arguments provide a weak framework to account for the production of the thermal spectrum. The problems are numerous, including 1, the validity of Kirchhoff's formulation, 2, the soundness of the local thermal equilibrium, and 3, the requirements for understanding the elemental composition of the sun, and 4, computation of the solar opacities. The opal calculation and the opacity project will be briefly introduced. These represent modern approaches to the thermal emission of stars. As a whole, this treatment emphasizes the dramatic steps undertaken to explain the origins of the continuous solar spectrum in the context of a gaseous sun. Sounds very interesting. So real quick, the thermal equilibrium thing is, they say that gravity is trying to, pull the star in and collapse it, but the sun is dissipating its energy, so that that pressure of all that heat escaping is basically counteracting gravity such that it doesn't allow the star to collapse in on itself. Like, that's their whole model is based upon that concept as well. And 1 second before we continue, I have to get some water. All right. Introduction. The mechanism by which the solar spectrum is produced has long preoccupied astrophysics. Citations 1 through 4. Though Langley established that the photosphere emissions generally conform to a black body line shape, 2 lines of reasoning initially prevailed as its formation. It was hypothesized that the photosphere contained condensed carbon, as graphite was a primer blackbody source on Earth. Alternatively, it was believed that the pressure broadening of hydrogen could account for the spectrum. Although Kirchhoff had formulated his law of thermal emission in 1859, observational astronomers appeared dissatisfied with this idea that Langley's spectrum could be produced assuming thermodynamic equilibrium and enclosure. They insisted on placing the carbon particles on the sun for 60 years and essentially dismissed any notion that Kirchhoff's laws afforded a sufficient framework to generate the solar spectrum. It would take the work of men like citation 11 and Schuster, citation 12, Schwarzschild, Eddington, Roseland, and Millen to finally remove graphite from the sun. These communications, in citations 12 through 23, formed the foundation of radiation transfer within stars. They consequently came to represent the heart of modern stellar physics. As a group, these authors used elegant approaches, but without exception, in citation 12 through 23, their mathematical treatment relied on thermal equilibrium and the validity of Kirchhoff's law, citation 10. In addition, since the standard model of the sun was deprived of condensed matter, astronomers would have to account for the production of the solar spectrum with physical atoms, ions, and electrons. Oh no! Graphite was gone, but the theoretical alteration solar opacity arguments provided a questionable replacement. All right. 2. Kirchhoff's law and local thermal equilibrium. Arthur Millen was perhaps the first to advocate that the interior of the sun could be regarded as existing in a state of local thermal equilibrium, citations 20 to 23. Millen's definition became central to astrophysical thought and will therefore be largely recalled. Quote, "It is convenient to have a phrase to describe the circumstances under the radiation J sub V equals K sub V, B times B sub V times T holds exactly." Yeah, I agree. When the small portion of matter has a definite temperature of T, it is behaving, i.e., emitting, as if it is formed part of an equilibrium enclosure at temperature T. We shall say that it is in local thermodynamic equilibrium at temperature T. We shall examine later the particular cases, the conditions under which the material is in local thermodynamic equilibrium. It is not necessary that the temperature shall be uniform. In a non-isothermal state, we may still have local thermodynamic equilibrium everywhere. The temperature may vary from point to point, but each point may be characterized by a definite temperature T, and the element of matter at each point may be behaving as if in thermodynamic equilibrium at temperature T. End quote. Millen's treatment, as centered on Kirchhoff's law, which is the J sub V equals KVBT, nonetheless, there was a risk that Millen's setting was so broad that virtually any non-equilibrium process, no matter how violent, could be considered in local thermal equilibrium provided that sufficiently small volumes of matter were being considered. No restriction was placed on confirming the validity of these arguments. That's cool. Oh, I forgot to do highlights. Nice. All right. Much like Millen, what's this guy's name?
Chandrasekhar.
Thank you.
That's the guy.
Thank you. Chandrasekhar described local thermal equilibrium as follows. We often encounter physical systems which, though they cannot be described as being in rigorous thermodynamic equilibrium, may yet permit the introduction of a temperature T to describe the local properties of the system to a very high degree of accuracy. The interior of a star, if in a steady static state, is a case in point. For even if the temperature at the center of the sun, for instance, were 10 to the 8 degrees, the mean temperature gradient would correspond to a change of only 6 degrees in the temperature over a distance of 10 to the 4 centimeters. This fact, coupled with a probable high value for a star absorption coefficient, enables us to describe a temperature T at each point of P such that the properties of the elements of masses in the neighborhood of P are the same as if it were adiabatically enclosed.
Adiabatically. You got it.
Adiabatically enclosed in a enclosure at temperature T. And what is P? Just the density? Is that what they're... P, point P. Yeah, I guess that would just be a point in the...
Likely, yeah.
Okay, yeah. Okay, so similar points were raised in Clayton's classic text. These discussions were focused strongly on the assumptions that pertain to a gaseous model. On the surface, it would seem that Chandrasekhar, Sekazar. That's not it. All right, what do you
It's
give me?
Chandrasekhar.
Chandrasekhar,
There you go.
Sakar. Chandra Sakar. Okay. Temperature gradient of only 6 degrees across 100 meters could be considered quite small, yet the oceans of Earth sustain convection currents based on a much smaller temperature gradient. In fact, oceanographers might reject equilibrium arguments globally for the oceans, even though these temperature gradients are on the order of just a few degrees over the span of 1,000 kilometers or of thousands of kilometers. The oceans contain convection currents as a direct manifestation of their lack of thermal equilibrium. Convection precludes the existence of equilibrium. As a result, a temperature variation of 6 degrees over a span of 100 meters could be treated as an enormous temperature gradient, not a condition approaching thermal equilibrium. The oceans demonstrate that Chandrasekhar's conditions, even if 1,000-fold, would still constitute powerful driving forces for convection, thereby eliminating all possibility of viewing the solar interior with interior as existing in a state of thermal equilibrium. Well before the days of Chandrasekhar, Millen elaborated further on the local thermal equilibrium in the gaseous framework. The interior of a star in a state of local thermodynamic equilibrium of this character. As we approach the boundary from the inside, the state of the local thermodynamic equilibrium gives place to an entirely different state in which the influence of external radiation on an element is paramount. It will be shown that when the element at temperature T is subjected to radiation, which is not blackbody radiation of temperature T, the extent of which it behaves is as if it is in thermodynamic equilibrium locally depends only on the relative importance of collisions as the cause of atomic absorption and emissions. If the atoms are sufficiently battered about by colliding with one another, they assume a state distribution of stationary states assume a state characteristic of thermodynamic equilibrium at temperature T. If they are not sufficiently battered about, their temperature becomes irrelevant and they emit and absorb at a rate which is determined by the incident radiation. It is clear that the collisions will be more enormous and therefore likely to be more effective at higher densities. This permits us to see in a general way why the state of local thermodynamic equilibrium in the interior of a star breaks down as we approach the surface. This assumption will certainly be satisfied in the far interior, since the limit at great distances, the conditions are those of an enclosure. It follows that the intensity of the radiation at this is delta sigma at d sigma.
Yeah, D-sig.
Yeah, at d sig In the direction theta is B sub V times T, the intensity of the radiation for the temperature T. So, let's see. The argument advanced by Millen was framed in a context of the laws of gases. Millen saw a rapid collision occurring at the center of the sun as sufficient to establish equilibrium, but the requirements set forth by Kirchhoff and Planck required something more significant. They demanded that the walls of the enclosure be rigid. Oh no! Ugh. So it sounds like they heavily committed to an explanation that would be favorable to them, just like mathematically. So far. And then we got, so let's see, so this is important. So I kind of remember this from the video. Have you guys watched the full video?
I think I watched the whole thing. I
Robitaille?
definitely watched
Yeah,
most of
I
it.
have it.
Oh, nice. Yeah, it's a banger. Let's see. So if gas in a highly compressed, if a gas is highly compressed, the collision with neighboring particles will enable a flow of heat through conduction. Gold has a density of 9.3 grams per centimeter cubed. and many solids have densities which are just slightly more than one order of magnitude, about a factor of 30, below the 150 grams per centimeter cubed hypothesized for the center of the sun. When heat enters solids, it can travel through conduction, either thermally through its vibrational lattice or electronically through the conduction bands. Clearly, gas cannot sustain conduction bands, but they are subject to thermal conduction processes, especially at these densities. As such, when an atom in a gaseous model vibrates at the center of the sun, it can transfer its energy to its non-rigid neighbor. Millen cannot assume that the atoms at the center of the sun are not devoid of collisional energy exchange precisely because the atoms are not rigid. The center of the sun cannot meet the requirements for a rigid enclosure as set forth by Kirchhoff and Planck. The arguments of the enclosure and local thermal equilibrium are invalid based on these considerations. At the time, Planck required that the source of the blackbody radiation was found in material particles. Planck's entire heat radiation, citation 9, was based on the analysis of measuring material oscillators not present at the center of the gaseous sun. For among all conceivable distributions of energy, the normal one, that is, the one peculiar to black radiation, is characterized by the fact that in the rays of all frequencies have the same temperature, but the temperature of the radiation cannot be determined unless it is brought into thermodynamic equilibrium with a system of molecules or oscillators of temperatures of which is known from other sources. For if we did not consider any emitting or absorbing matter, there would be no possibility for defining the entropy and the temperature of the radiation, and the simple propagation of free radiation would be a reversible process in which the entropy and temperature of separate pencils would not undergo change. Now, we have deduced in the preceding section all the characteristic properties of the thermodynamic equilibrium of a system of ideal oscillators. Hence, if we succeed in indicating a state of radiation in which the thermodynamic Hence, if we succeed in indicating a state of radiation which is in thermodynamic equilibrium with the system of oscillators, the temperature of radiation can be no other than that of the oscillators, and therewith the problem is solved. So, is he saying that for them to figure out how hot a black body temperature, like how much that's emitting, they need to reference something of a known temperature to transfer that to, and then whatever that temperature is becomes, that's what the black body was. Is that kind of what they're getting at? That's what it seemed like to me.
Sounds about right.
All right. Max Planck required a perfect absorber be present in order to produce blackbody radiation. Millen neglected this important line from heat radiation. Hence, in a vacuum bounded totally by reflecting walls, any state of radiation may persist. Planck then argued that if an arbitrarily small quantity of matter was introduced, the radiation in the enclosure will change to a new state. However, it will not be a blackbody state unless the substance is not transparent for any frequency. Unless the substance is not transparent for any frequency. Planck chose a piece of carbon to ensure blackbody radiation. The desired radiation does not simply appear. As Millen in his oh yes, I see. You have to, gotcha. Such as Millen and his contemporaries surmised, the presence of the enclosure by itself could have the presence of an enclosure by itself could never satisfy the requirements for the production of blackbody radiation. Planck insisted throughout heat radiation on his paper titled Heat Radiation on the need for a physical oscillator, and he reminded his readers that only material particles can be involved in the emission and the absorption. The physical oscillators, which acted as a perfect absorbers, must be present. Miller has not advanced such a species at the center of the sun. Instead, Millen, like Schuster, Schwarzschild, and Eddington before him, automatically presumed the invocation of Kirchhoff's law provided sufficient proof that the interior of the sun harbored blackbody radiation despite the absence of a rigid body enclosure required by Kirchhoff. That sucks, dude, when you accidentally assume the thing in the sky is the same as the thing in the lab. Super unfortunate.
Dude, it's worse than that because it's in a vacuum.
But dude, it's just
there's so much pressure.
There's so much gravity, and you just don't understand. You just don't get it.
Yeah, I don't see the term ideal gas law used yet.
Oh, we're going to get to the ideal gas law, hopefully, because he did you've seen the video, Stone. I thought that was a super fascinating point because we actually argue that all the time, right? How, if there's nothing to push off of, how doth thy have thy pressure? How do you, what part of the gaseous blob decides to become the center to which all things conform to, etc.?
Exactly.
And it's like you can't have pressure without... Dude, how crazy is that? He's making our argument, but just doesn't realize that, it where it actually applies. So, very cool. Blackbody radiation was inserted at the center of the sun without any requirement on the material generating the needed photons. All that was required was the enclosure, even if not strictly rigid, and a newly hypothesized local thermodynamic equilibrium. For Millen, the presence of an enclosure was ensured by the hypothesis that the density at the center of the sun would be sufficiently elevated to restrict photonic and atomic diffusion. Nice. In reality, Millen's idea fell short for the requirements to produce blackbody radiation. He was considering a setting where conduction, not radiation, could dominate heat exchange. Consequently, his arguments relative to radiative heat transfer were without strong scientific justification. Millen had neglected the observation that the collisions of adjacent atoms constituted the universally accepted exchange mechanism for thermal conduction, not equilibrium. Ooh, unlucky. It was for this reason that Planck insisted on the rigid enclosure. Planck knew what was up. A careful review of blackbody radiation has revealed that the production of the spectrum always requires the presence of a perfect absorber. Planck himself constantly brought forth the carbon particle as inherently linked to the validity of his argument. Yeah. Oh, no way. He used like science and evidence and the experiments to back up his point. That's crazy. What kind of madman was Planck, dude? That doesn't make any sense. Does he not know? All right, let's see. Planck himself, okay, Kirchhoff's reasoning that the adiabatic,
It's the old
adiabatic enclosed adiabatic enclosure could contain black radiation has been exposed as flawed, and the law of thermal emission is erroneous. Dang. The universality of blackbody radiation simply does not exist. Yet even if Kirchhoff's law was valid, Millen's argument was fallacious, as he lacked both the rigid enclosure and the materially perfect oscillator required by Planck. Jesus. Highlight the whole thing. Fuck it. All right. Solar and stellar opacity. Solar opacity plays a vital role in all modern gaseous models of the sun and is currently at the center of our understanding for the stars. Therefore, the study of solar opacity has a far-reaching implication throughout modern astronomy. Opacity, noted by kappa, refers to the ability of a material to absorb incoming radiation. Monochromatic opacity, kappa sub v, is associated with a single frequency. The excitation coefficient alpha, centimeters negative 1.
That would be alpha per centimeter. It's the extinction coefficient, by the way.
To the
I'm
power
sorry,
of the negative 1 power.
Okay, the extinction coefficient alpha is
Per centimeter.
Per centimeter. That's all you say is just per centimeter?
Yeah, it's viewed as a denominational or a denominator kind of coefficient.
Okay. It is equal to the opacity kappa centimeters squared over g.
Square centimeter per g per gram.
Square centimeter per gram. Yeah, multiplied by the density of the material rho.
In grams per cubic centimeter.
In grams per cubic centimeter. So cubic negative centimeters. Man, okay. I'll let you handle
it's
that.
It's the first dimension, the second dimension, and the third dimension. See the way the exponents are going up?
So I see.
Alpha, the extinction coefficient in alpha per centimeter is equal to the opacity kappa in square centimeter per gram multiplied by the density of the material rho in grams per cubic centimeter.
Oh, I see. Okay, so
1 by
okay.
2 by 3.
Yep,
Hmm.
starting to make sense when you say it like that. So the extinction coefficient. So be the least amount to the most amount.
They're showing how a 1 coefficient is applied to opacity and then brought into the third axis through the density factor, right? There's it's just a question of how much is in between you and something else and how much you see it, really. This is all that we're talking about here is gas density, and we're calculating monochromatic opacity and brightness here. So these are the factors in play.
Where's can you scroll? Is there the formula for this shown somewhere?
Just this right here.
Gotcha. So it's just that
Cool.
straightforward, huh?
Yeah, so just the denser it is, the more opaque it becomes. No way. All right. To calculate the opacity within the solar interior, solar physicists first accept that the sun can radiate internally by itself. This constitutes a notable departure from the rest of the earthly physics. I love when solar physics departs from earthly physics. That's when you know you really got something going that's super viable. For all objects on Earth, internal heat transfer occurs through conductive and convective paths, not internal radiation. Radiation allows radiation allows for an object to achieve thermal equilibrium with one other or with one another, not within themselves. Not within themselves. So it doesn't it's equalizing to like its environment, not like with respect to itself. It's self-regulating. Is that kind of what they're saying? It's solving it. Okay.
They're talking about the process of reaching equilibrium, molecule to molecule or atom to atom, and that the term doesn't refer to what happens within a single unit, more how radiation of the units themselves tend to achieve thermal equilibrium of them all in the process, giving heat to each other and equalizing radiatively.
Gotcha. All right. As the result, the idea that the sun transfers internal energy through radiation directly implies that astrophysics treats the solar interior as the sum of its individual atomic, ionic, and electronic species. The sun as an angle, or the sun as a single, wow. The sun as a single object does not exist in a or exist in gaseous models. The sun is a single object. Gotcha. Okay, yeah. It only in such a scenario would internal radiation permit the transfer of energy between the constituted objects which make up the sun. Still, Millen required that within the center of the sun, atoms, ions, and electrons were packed such that collisions occur. This scenario rendered conduction probable, greatly impacting any radiative field. In the gaseous solar models, thermal photons at X-ray frequencies with the characteristic blackbody appearance are believed to be produced at the center of the sun over the course of thousands. Dude, they're just chilling for thousands of years. That's badass. Eddington stated that these thermal photons slowly leaked out of the solar body. Yeah, he did. As they traversed increasingly elevated layers of solar mass, photons gradually lose some of their energy. The entire solar spectrum was shifting from X-ray to the visible range while preserving a black body appearance.
Yeah, right.
Why not?
Dude, Eddington had quite the imagination.
Dude, he's got his fingerprints
Got those-
all over everything. It's
I can just
insane.
I could picture each of these little photons with their own little gas fuel gauges, you know what I mean? Oh, we're losing some energy, oh no!
Oh, it's awesome. All right, so 3.1 opacity mechanisms. Stellar opacity involves the removal of energy from a beam of photons originating from the core of the sun through four mechanisms. 1. Bound to bound. 2. Bound to free. 3. Free to free. And 4. Scattering processes. Processes. I like processes. So, anyway, for the excellent description, bound-to-bound processes rely on spectroscopic line absorption, either within the atom or an ion. Bound-free mechanisms result in the dissociation of a previously bound electron by an incoming photon. The electron becomes completely free in the atom or the ion. Free-to-free processes are the inverse of the Brimstrom mechanism, whereby a free electron and an ion interact during a time that combines species, in which time the combined species is able to absorb a photon. The scattering mechanism is the momentum of the photon is being transferred to the scattered electron. Oh, no way, there's Compton scattering going on in the sun, lads. That's what's up. Theoretical astrophysics calculates opacity for the sun by taking in the summation of these processes for all atoms, ions, and dang, they counted down to the ion, dude, and the electron. Crazy. And the temperatures within the solar interior. The negative hydrogen ion was
Whoa. Hold on. That sentence. Go back up. Hold on. Can we read that sentence again?
What's up?
Just go back to the start of that sentence in the previous page. Listen to this sentence, man. Theoretical astrophysics calculates...
Theoretical?
Go ahead.
Yeah, okay. Theoretical astrophysics calculates opacities for the sun by taking the summation of all these processes for all the atoms, all the ions, and all the little baby electrons, even though we can't quite, know where they're physically located, but we know they're there, at all the temperatures within the solar interior. That's what's up, dog.
Even though they can't see a solar interior.
It's theoretical, bro.
Whoa, boy. Just think about it. Like,
where's your model of the sun? Dude, imagine having to replace this. Like, dude, this is all we have to replace. This is easy. This don't even work. This isn't even real.
Like, how deep of lore are we in? Like, this is...
Oh, we're in it, dog.
This is like... You're getting so deep in the weeds. This is... it feels just like reading about the geodynamo, man. It feels just like that. Like, every single one of these processes, like, this is just... They're bragging so much about their level of precision for a bunch of values that are fabricated.
But they're really precise with their decimal places. So I feel like if you're gonna refute them, you need to move some decimal places. All right. So thank you for pointing that out. I glazed over it, dude. The negative hydrogen ion was advanced as a significant determinant of solar opacity by Wildt. The concept immediately received support from... Don't tell me. Chandrasekhar.
Yes!
Chandrasekhar. I did it. Chandrasekhar, who calculated that the negative hydrogen atom within the context of the gaseous solar model could contribute greatly to the solar opacity in the 4,000 to 24,000 Armstrong range, or Armstrong?
Angstrom.
Thank you. The Angstrom range. Of course, the negative hydrogen ion spectrum extended over much of the photospheric emission at 2,500 to 25,000 angstroms. Nevertheless, the negative hydrogen ion could never, by itself, generate a continuous solar spectrum with its characteristic thermal appearance. For the gaseous model, the production of the thermal spectrum involves the slow conversion of a hypothetically X-ray blackbody spectrum produced in the solar interior of the visible spectrum observed at the photosphere. Thus, if a blackbody spectrum did exist at the center of the sun, it will be characterized by a wind displacement temperature of about 15 million Kelvin. Such a spectrum would be centered in the X-ray region. It would then have to be gradually shifted while always maintaining its thermal appearance to a much lower frequencies. Consequently, astrophysics is requiring that a perfect mixture of atoms, ions, and electrons exist at all the layers within the sun. Isn't that nice of them? They can just do that. In each layer, these mixtures.
Otherwise it wouldn't work, right?
Dude,
Sorry.
imagine if we proposed some stuff like that's so crazy to like see how they've done it and proposed it, and then like if we say one thing, we're like word salad, that's retarded. like my man,
where's your evidence?
Dude, my man just surmised 4 different factors that no one's ever confirmed or know how they exist that reify several different models to conceptualize a temperature reading of of how they can interpret.
We're like, hey, maybe if it's if it's liquid then or fluid, then maybe it's gonna refract a little bit and you're not gonna actually see its real position. And they're like, nah, you can't possibly think that. But I mean, it's demonstratable.
Crazy. Let's see. In each of these layers, these mixtures could then produce the desired local blackbody spectrum. Nice. Within each solar layer, the new perfect mixture must exist in order that its absorptive characteristics enable the production of a new shifted thermal spectrum.
Oh, right where they expected it.
Dude, they found Kirchhoff's law right where they were looking for it. They found it right in the center of the sun, where there is an evenly distributed layer of electrons, atoms, and ions. That's so cool. That's so cool. Therefore, despite Chandrasekhar's findings, the computation of the solar opacity had remained a tremendously complex undertaking. For example, the American astrophysics community has invested heavily in calculating the opacity contribution from neutral and ionized gases. In a project involving internal collaboration with the Los Alamos National Laboratory, led Project Opacity provided as a absolutely phenomenal treatment of nearly every possible atomic species inside the stars in widely varying states of oxidization. Similar findings have been obtained at the Lawrence Livermore National Laboratories. These students have resulted in the opal opacity values, but none have the opacity mechanisms considered by the methods. By these methods can be used to explain the origins of the blackbody spectrum in graphite. This suggests that these mechanisms are not truly related to the solar spectrum. Dang, so they got some good numbers, dude, but they don't reflect the mechanisms necessary to produce the spectrum. Roslin mean opacities. Rosalind?
Yeah.
The determination of internal solar opacity values must be performed at individual frequencies of interest, since the production of the blackbody spectrum always remains frequency dependent. The problem becomes so overwhelming that astrophysics has astrophysics has chosen to adopt Rosalind mean opacities. Through Roslind's approach, a single frequency independent of the value of the opacity can be obtained for each solar level. On the surface of it, it could be argued that Roslin mean opacities merely reduce an otherwise intraceable problem. No,
That would be
yeah,
intractable.
intractable problem. The lower computational requirements and greatly simplify the presentation of the opacity data. The lower computational requirements and greatly simplify the presentation. The Rosalind mean opacities enable solar physics to sidestep the reality that at each level of the solar interior, it is impossible to generate a purely blackbody spectrum with a strict adherence to a Planckian behavior at all frequencies. It is not feasible to build a blackbody spectrum from the sun of non-blackbody processes. For instance, during the computational stage, a single bound-to-bound transition will introduce a, quote, spike-like contribution to the calculated spectrum, each, quote, spike being associated with the line absorption. Such a, quote, spike must be compensated by using the sums of the processes, other bound-to-bound processes, or bound-to-free processes, or free-to-free, or Compton scattering mechanisms that are going on inside of the sun, whose existence will always remain in doubt at the levels required to incorporate the initial, quote, spike Jesus.
This is nuts.
Into the final solution of the black body line shape. The entire process becomes an exercise in parameter fitting,
That's
devoid of
that's
any
certainly what it sounds like.
confirmatory physical evidence.
Woof.
Just
Yeah,
more
how do I highlight all
reification.
of that?
Yeah. Man, oh
How do I-
man, that's nuts. Just up, we can just we've got a few different processes we can throw at this that that we have some formulas for that will take care of the spike. Don't worry.
Shout out to Rosalind, dude. Without him and his mean opacities, this would be a huge problem for those who believe in the gaseous nature of the sun. Still, Rosalind mean opacities mean at the heart of the modern solar remain. Oh, sorry, they remain at the heart of modern solar models. Within each layer, the sun, a mean opacity can be inferred based on the expected atomic, ionic, and electronic species. However, the sum of the processes bound to bound, bound to free, free to free, Compton scattering, utilized in Rosalind's mean opacity computations cannot be infinite. Thus, rather than analyze the mean opacities, scientists can convince themselves of the futility of these approaches by taking the mean opacity solutions and using the same species in concentrations to calculate the associated frequency-dependent spectra. Such solutions will not correspond to a blackbody spectra. As a result, Rosalind mean opacities form a weak foundation for the gaseous solar model. The summations of numerous spectral processes, which are individually unrelated to thermal radiation, can never give rise to a truly black spectrum.
So yeah, to the logic fan who threw a comment in that said, if the sun emit a black body spectrum, isn't that firm evidence of the sun being a physical object with a real surface? Is this compatible with the sun only being apparent in flat Earth? And so there you go right there. The summation of numerous spectral processes which are individually unrelated to thermal radiation can never give rise to a truly black spectrum. So, I don't know, maybe just kind of listen up, and we can also maybe talk about that a bit more after this is done.
Nice. All right. So 3.3. Oh, nice. We're almost done. Cool. All right. Where were we at here? So 3.3, elemental compositions. To further complicate matters. Oh no, it gets worse. Dang. The computation of the solar opacity as a function of depth requires that the elemental composition of the sun remains dependent on the spatial or remains independent of spatial positions. Such a requirement can never be justified. Our current understanding of solar composition rests and will always rest on that which can be evaluated at the level of the photosphere. All extensions of the solar composition to the interior and all the claims of the constant element constitutions within the depth should be regarded as scientific conjecture. Nice. So, let's see, to further complicate the matters, so talking about the elements that make up the sun, you can't judge what's going on inside, right? We can only judge based on what we can see from the photosphere, like what we can actually get a reading off of, right? Not what we can infer through mathematic processes. Very cool. For conclusion, through opacity considerations, solar physicists believe that the X-ray-based blackbody spectrum produced at the center of the sun can be emitted at the surface in the visible range. However, from the moment that the sun was hypothesized to exist in the gaseous state in the mid-1800s, objections were raised to the ability of gases to emit a blackbody spectrum. Classic, dude. They've known since the 1800s.
Because it is paradoxical.
Wow.
It is paradoxical.
The interior of the gaseous sun was thought to be essentially transparent to radiation. This was the position advocated by Herbert Spencer when he complained that if the sunspots were openings in this photosphere, one would be able to see through them and out to the other side. In fact, the same famous objection was voiced by Kirchhoff himself. According to Kirchhoff, the interior of the sun could only sustain blackbody radiation if it were surrounded by a condensed photosphere. Kirchhoff well understood that no gas in isolation could ever produce a blackbody spectrum. The presence of a condensed matter is always required.
Wow.
Always requires a container. In support of Kirchhoff's liquid photosphere, there are numerous lines of evidence that this photosphere is condensed matter. Granules, sunspots, and limb darkenings provide additional evidence. Sunspot emissivities are highly suggestive of metallic character, strengthening the case of condensed matter. All of these factors should be considered when advancing the proper phase of the photosphere and the mechanism associated with solar thermal emission. Nonetheless, despite the clear violations with regard to the enclosure, thermal equilibrium, and the presence of a perfect absorber as required by Max Planck, solar physics has tried to account for the generation of the Planckian spectrum, yet none of the mechanisms advanced can be used to explain the thermal spectrum of graphite itself.
Wow.
Womp womp or whatever.
I never knew that.
Yeah, apparently, graphite's emits blackbody radiation. Right? Is that what y'all are talking about? In the sun?
Yeah, that's what they were doing the testing on back in the day.
The thing is, it's a solid.
Yeah, so I think there's people that think that the outer shell of the sun is like molten graphite crystallized or something like that. I don't know. It's some.
But even then, it's not going to appear black, right? It's just bizarre.
In fact, although physics advocates advocates an understanding of internal thermal radiation within the sun, it has produced no mechanism by which the simplest earthly spectrum can be explained. This constitutes a powerful reminder of the tremendous difficulties or that tremendous difficulties remain relative to the science of blackbody radiation. One second, that cleared my throat. All right, blackbody radiation. Let's see. In the end, stellar opacity calculations represent a myriad of physical impossibilities. Nice. That's my favorite type of myriad. None of the suggested opacity mechanisms, bound to bound, bound to free, free to bound, free to free, and scattering are related to the emissions of a single photon by graphite. Unlucky. As such, beyond the inability to support structure, the shortcomings of a gaseous solar model rest on opacity. Even though Millen and his predecessors were incorrect in inferring that the blackbody spectrum could be produced at the center of the sun, the gaseous model contains numerous other stumbling blocks on their way to generating a continuous spectrum at the solar surface. A truly remarkable thesis has been advanced to explain the photospheric spectrum within the gaseous model. In the end, astrophysics has championed a solution for obtaining the solar spectrum which cannot survive the careful scrutiny of spectroscopic scientific or scrutiny of these photosphere of the man. In the end, astrophysics has championed a solution for obtaining the solar spectrum which cannot survive the careful scrutiny of the spectroscopic scientific community. Each spectroscopic signature in nature is linked to a unique physical process. For instance, the Lyman or Balmer series can only be produced by electronic transitions within the hydrogen atom. Similarly, atomic line spectra are unique to each individual element or ionic species. Nuclear magnetic resonance (NMR) spectra are obtained from particular spin transitions within a well-defined physical and experimental context. Physics does not search for the Lyman series in the NMR spectra. One process is electronic, the other nuclear. Within the gaseous sun, modern astrophysics currently believes that it can produce the graphite spectrum using processes which do not exist in graphite. Dude, wasn't there a song by that band, Graphite Sun, Won't You Come? You guys know that one? In its interior, to the advance that the blackbody spectrum can be produced in the sun using the physical
mechanism. It is improper. Alan, beginning of the sentence. Interior, no, it is improper to advance.
Oh, my bad. Sorry, I was thinking about graphite sun. It is improper to advance that the blackbody spectrum can be produced in the sun using physical mechanisms which are not present on Earth within all black bodies currently studied in our laboratories. Shout out to you, boy. Well said.
We've never seen it happen. It's never occurred in any observations, but we're just going to presume that's what's happening.
If it's not in the lab frame, GTFO. Quote from Perry Marie Robitaille. Paraphrasing, of course. The use of a nearly infinite sum of atomic and ionic and electronic processes, which can alter their absorption and emissions precisely in a manner which preserves the black body appearance of the solar spectrum at all depths within the sun, represents a non-scientific exercise based solely on the desire to salvage the gaseous equations of state.
Burn.
Damn, what a sick dunk, dude. I love academic burns. Those burn the hardest.
They do.
That's a black body burn, dude. I don't even know where to start the highlight to get it. I guess the whole thing. Anyway. It is well known that the thermal emissivity in gases can drop with increasing temperature. Neither pressure broadened gases nor any of the atomic, ionic, or electronic processes advocated in the interior of the sun have a fourth power of temperature behavior. Furthermore, the gaseous models depend on knowledge of the interior constitution of the stars based solely on the elemental constituents. Or yeah,
Those are constituents. Yeah.
constituents. Yeah, constituents. Okay, thank you. Mankind will always lack such information. No, we can get inside the star and know what's inside of it, Pizio. Don't laugh at that.
I like this guy. It's like this is how people with brains think, but I feel like so often in academia they just advance narratives without thinking about them.
Yeah. One sec. As a result, this work constitutes an invitation to reconsider the phase of the sun. The gaseous models suffer from two insurmountable weaknesses. One, the inability to account for the photospheric structure. That's a huge problem, like the one thing that they can look at and observe. Right? They can't explain what goes on there. And two, the lack of a proper mechanism to generate the thing that they're observing. Nice. Observational physics. It's the worst of both worlds, I guess. Observational physics for them. Observational physics has long documented the existence of the features of the solar surface which demand the presence of condensed matter. The belief that opacity arguments can account for the illusory nature of the solar surface and all associated structures discounts the realization that the photosphere also behaves as condensed matter. Helioseismology.
Helioseismology.
Yeah, it was the hyphen was throwing me off. Helioseismology demonstrates that the sun acts like a resonant cavity. No way.
Hold on a second, bro. Are you
That's
telling me
interesting.
sky crystals?
I mean, the sun's just up there singing a harmonic frequency, bro. Like, I don't know.
He's saying it's solid, bro.
Just more crazy talk.
Let's see. On the Earth, resonant cavities are manufactured from condensed matter. It is not reasonable to expect that the gaseous sun can create an illusionary surface in its visible range using negative hydrogen ion opacity, while at the same time, in the same layer, produce a surface which is nearly perfectly reflecting for wavelengths which extend over many thousands of meters. Such are the requirements if the sun really acts as a resonance cavity. Perfect resonators sustain standing waves which are never absorbed.
Well,
According to, hold on, let me finish this out, bro. I wanna wrap this up. According to the photosphere of the gaseous sun, must be strongly opaque in the visible region while powerfully reflecting in the sub-audio. In addition, the gaseous model must account for the presence of the transverse waves on the surface of the sun when the gases are known to sustain only longitudinal waves. It remains that the case of seismology in the sun. It remains the case that seismology is a science of condensed matter. To account for seismological behavior in a gaseous sun, using the sun opacity arguments constitutes a significant departure from accepted earthly physics. Almost done. All right. Given the problems which surrounded solar opacity, it remains difficult to understand how the gaseous models of the sun have survived over the 20th century. Indubitably. It's almost like they don't want to give it up for some reason. It's like they're worshiping it or something. Local thermal equilibrium does not exist at the center of the sun. Both Kirchhoff and Planck require rigid enclosures, which is not found in the sun. Planck has also warned that the sun fails to meet the requirements for being treated as a black body. Millen's rapid collision regime constitutes a path of conduction, not equilibrium. Millen and his contemporaries cannot infer that a black-body spectrum exists at the center of the sun based off of Kirchhoff's laws, even if the law was valid. Unfortunately, not only does the sun fail to meet the requirements for the enclosure and local thermo-equilibrium, but Kirchhoff's law itself is erroneous. The production of black-body spectrum requires the presence of a perfect absorber. Max Planck appeared well aware of this reality, as he cited it a whole bunch and every time he ever talked about it. The gaseous opacity arguments will always fall far short of what is required. In the end, the mechanism used to generate the solar spectrum should be shared with graphite itself. It is most likely the physical cause. The most likely physical cause remains the vibration of the atomic nuclei within the confines of a layered graphite-like lattice. Dedication for this work is dedicated to my sister Lydia and to her children. Help me out, Stone.
Fabienne et Louis.
Yeah, thank you, sir. All right, shout out to the Robotize.
Well, so this dude is saying that the sun is a giant crystal lattice graphite structure.
Of plasma.
Well, yeah, because it's so hot, it's not in solid form anymore. But yeah, a plasmized crystal lattice graphite structure. Huh.
Yep.
Molten sky crystal.
Yep.
This is like lepers arm wrestling. It's like this. No,
yeah.
It's your theories are shit, man. It's most likely it's like that.
So I like that he's trying to relate it to, because obviously, like, he's not going to be like, well, the sun's not a physical object, right? Like, he's not going to take that approach. But they get these readings, and he's got this model, this interpretation, these distances, right? This conceptualization, and he's trying to make it at least apply to things that they experience in the lab, which I respect.
Yeah, at least he's not just inventing up completely new fields of physics with no observational conformational potential at all.
Yeah, but that was that was an awesome read, man. Definitely a lot to dive into and keep building upon. But yeah, that was the introduction to it. I think someone said from the chat that they wanted to come on Discord, so I guess we can.
Nice. Yeah, sorry to the Logic fan. I kind of misunderstood your question a little bit when I read it earlier, so I'm sorry if I sounded a little angry when I did. But to try and answer your question about the sun being a black body spectrum, I really don't know. I can't tell you what the sun is or what medium it's in. It would be pretty massive speculation. And then the Logic fan says Robotai is saying that it's made of semi-metallic liquid hydrogen, not graphite.
Yeah, not graphite, but he compares like he shares the sentiment that it should be able to produce the same spectrum, like the mechanism should be the same, and not just some made up DS squared, which is the worst kind of DS. Right.
You're not taking that. You're not taking the D over DDS.
No.
Isn't this the dude who was like called out by Professor Dave and then he replied and smacked him back?
Yeah, we watched a little bit of the video at the beginning.
Okay. Yeah, this guy. Okay.
Yep.
Sky Scholar.
Yep.
Yeah, when I watched a little bit of that, when I heard him give the explanation of the container, I was like,
Yeah.
huh.
Yeah. I was like, no way. You don't say. Because when we say that for a different purpose, everyone freaks out.
Yeah. It
But it's
was
good to know we're on the right path. Right? Like it is a thing.
I mean, to be fair, they do freak out a bit when he says it too.
Yeah, but they freak out like differently.
I mean, when you're getting a Professor Dave video just to smear you, they're freaking out.
That's true. That's true.
Is there a dude who was like called out by Professor Dave and he replied and smacked him back? Yeah,
Yo, what's
Dude,
up, RG?
What's up, guys? How are you?
Just chilling.
Let me turn this down here in the background. I got an echo. 1 second.
Yeah, when I watched a little bit of him give the explanation of the container. I was like, yeah, I was like, ah.
Is there a
Oh,
conversation in the background,
Yeah.
RG?
No, he's
There's quite a bit of lag.
yeah, he's trying to get that sorted out. I'm gonna mute you for a second while that catches up and you get that sorted because it's just replaying back. As much as I like hearing Pizio in the background. Just kidding.
Right.
can you go to 1913 in the video whenever you play it again?
Absolutely. 1913. Give me 1 second. Let me switch screens so we can hear the audio.
Can you guys hear me okay?
Yes,
Yeah.
sir.
Loud and clear.
Awesome.
What's up,
Awesome.
buddy?
Awesome. Oh man, just relaxing, bro. I had a little bit of a problem keeping up with all the information, but if you guys are ready for a question, I got I guess a good question. I think so.
Yeah. Yeah, absolutely, dude. Send it. What you got?
So I heard a lot of the assumptions in that paper that they were making, kind of jumping the gun, like almost trying to force the point. Talking about a vacuum and you know, if you empty out the vacuum and it's the best we can get here is like what, -6 or 7 torr in a vacuum chamber. And he said nothing or that couldn't produce the black body radiation or conductivity. But if you dropped one carbon atom in there, that's like, how does a black body energy or radiation even begin if there's nothing to like split it? Kind of like our cells, it'll just keep splitting itself and growing exponentially at some point. Is that what they're trying to get to about starting it like that in a vacuum experiment?
Stone, do you want to take that? I have no idea. This is like a whole new subject for me. Like black bodies
Right, me
and
too. I
solar
mean, well,
structures and stuff. Yeah.
yeah,
There are just
that's
so many
crazy.
paradoxical elements to this paper and the mechanisms they're describing. I'm sure you're learning. You're starting to
Yeah,
embrace them. It sounds like.
yeah, because it
Um,
kind of, and the other part I caught that really caught my attention
no,
was
I wanted to deal with that.
they were
The
kind of
question
blood.
first. Hold on. Just deal with what you were just saying. Sorry, I'm almost
Go
there.
ahead,
Yeah, no,
gotcha.
there's a little bit of cart before the horse in the logic is what he's trying to point out, like where did the graphite come from? That it's kind of a chicken and egg thing where there may be some previous star that produced this material. Well, how did that previous star form if this one's not going to form with it? is the question.
Right.
You know what I mean? So
Right. Right.
I got a feeling some of your subsequent questions will be simply observant of the same paradoxical angst I feel with you.
Uh-huh. Yeah. 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 The next one I have is I guess it was along the same line, but they're using a different analogy this time with uh, gaseous. Uh, there's not enough gaseous collisions of the paper specifically said it falls far short from what's required to get this effect from there to here.
Exactly. What they're trying to do is violate the reality of what gases are and do at their energy state, and that
Uh-huh.
we're implying some kind of inward force to dramatically increase the density to the point that it's going to act like a non-gas. And again,
Uh-huh.
more mathematical magic that we've never been able to achieve in the lab or any other form of the imagination or mathematics. It's just another thing they're saying, well, that's probably what's happening because this other thing we think is happening is probably also happening. And if that's got to be happening, then this must be happening. And therefore, that's how
Yeah.
we know this fourth thing is happening. And it's all
Yeah.
based on the
That
probably
language.
things
Yeah.
happening, right? So what they're doing
Yeah.
is
That language.
they're trying to redefine the boundaries between phase here even in terms of its characteristics between conductive energy heat transfer and radiative heat transfer, which is what gases typically do. They're
Hmm.
just trying to break the laws for
Okay.
the sake of their own convenience to keep the theory alive.
Yeah. Yeah. It's almost like a transfer of information, like a LCD screen would produce certain colors that are certain temperatures and wavelengths. Uh, the smaller, more rapid wavy ones, and then that kind of like microwaves and X-rays kind of merge into what we see in the physical spectrum of colors, and then when that ends, it goes on to bigger, wavy, like very slow, kind of heavy, dense waves, I guess you could say. And I'm just here to say I'll let you guys have it, but I see the closest experience I've had with the transfer of color to my eye was when I shot you know, and I shot the nail through my eye. I think I told y'all about. I'll put it in the
Yes, don't
chat.
go there again,
Just let
please
me know.
don't.
Well, I'm not. It's got something to do with the transfer of that information to us. Is there some kind of truth in the middle of that? When
Well, I would
carbon
bring you
lines or
back to
whatever?
the middle of the paper when they were talking about the X-ray spread and that how that had to somehow magically shift spectrally towards the visual spectrum. The visual
Mhm.
part, the very narrow band we call the visual part of the spectrum. X-rays are like
Mhm.
so much higher frequency. And
Yeah.
somehow it's a mass-induced effect in spectral shift. Again, something we've never seen in reality, but they're assuming has to be happening here because when we look up and we're assuming that it's a giant ball of gas and we're seeing these frequencies and we know that these mechanisms have to occur first and those happen in the X-ray in X band and we're not seeing that. We're actually seeing stuff lower down, so there must be a shift going on. And there's no evidence for it.
Yeah.
There's no logic for it. They're just saying, therefore, it must because reification.
Yeah. Yeah. They're trying to force that earthly physics and astrophysics onto our understanding of basic spectrum of light that we see. And last thing is, when the fluid drained out of my eye, I didn't know this at the time, but
I
it's
did
liquid
ask you not to
crystal.
go there.
All
Ugh.
right,
Wow,
we can
man.
it's all good. I'm tired of hearing about High Guy. Um, what's the next? Do we have anything else? Any other questions?
I don't think I have any other questions per se. Just would shout out Sky Scholar big time and say everyone
That's a
should go
cool.
check out some of his content. Especially
He's got
that full video I would definitely recommend.
Yeah.
dude.
Oh,
Yeah.
Oh,
Go
and
ahead.
the relativity video.
Yeah, he's got some awesome videos on all this stuff. So black body radiation, what's up with the sun, different types of stars, like all related to the spectroscopy stuff, his own interpretation of the sun in case you want to get your liquid metallic hydrogen on. And if you're feeling like, breaking relativity, you can check out his relativity series where he has people come in and body bag relativity from its own mathematical structure.
Does he talk about the thermodynamic violations of a gas being able to collapse in on itself inside of a vacuum and overcut, like when it's naturally a dispersive state of matter?
He does.
Huh. Makes
Man,
sense.
we should just go through and read all the questions and answers. Or we should read Brenner's question from 7 years ago where he asked about that. And then people started trying to give him answers, and he just fought with them in his comments for, I don't know, probably the last 7 years.
I think a lot of people just don't pick up on that physical mechanism they deem the Chandrasekhar limit, which is the thing that causes stars to, quote, implode and demonstrate for us what they say is going on. Just trying to establish that in a vacuum is a staggering leap of logic just on its own.
Well, are you gonna? Oh, by the way, can you play the little clip, Alan? Because I think it's like really relevant. The 1913 clip.
Oh yeah, my bad, dog. Totally forgot about that. Fucking eye guy came in and
Any of the heavy
eyed all
elements.
over the place. See, what do we got? 1913.
Yeah,
Got you, Birdie.
you're at 13 right now. 1913.
Oh, the other
It's
19.
his
My bad.
method.
Yeah, Stone knows what's up. 1913. There we go. Sorry, I'm dyslexic.
Okay, let's go over this. I never stated that the pressure exists only at the surface. I stated correctly that it was generated at the surface. The effect is then transferred throughout the system. The ideal gas law in chemistry was discovered using real containers, not imaginary boundaries. That is something you'd learn when studying the kinetic theory of gases in third-year physical chemistry courses or in graduate school. Here's an easy online tutorial for everyone to learn that the generation of pressure in an ideal gas is all about the momentum change at the wall of the container, and this is taught by a physics professor. The tutorial properly neglects the force of gravity, as gravity is not part of kinetic theory. Gas particles only have a net change in momentum at the surface of the container, and that is where pressure arises. That is why pressure is equal to force over area. Now think about this equation for a moment. Force is equal to mass times acceleration, and acceleration is equal to a change in velocity over a change in time. You can't get a change in velocity using an imaginary surface. If we were to imagine a gas and an imaginary surface, we can also imagine the fact that there would not be a net change in momentum at that surface. Why? Because it's imaginary, just like the tooth fairy or unicorns. Imaginary surfaces are used in physics, but only in assessing things like flux, not something like pressure. Dave also does not properly understand the difference between simple and complex systems. The gaseous stars are simple systems with one state of matter. They have no surfaces and therefore can never generate the electron gas pressure that the standard model requires. In contrast, the atmosphere of the Earth is complex, with both a gaseous atmosphere and the surface of the Earth itself. The latter, as a ball of condensed matter, exerts a gravitational force on the gas. A net change in momentum occurs when the gaseous atoms strike the surface of the Earth, producing gas pressure in the atmosphere. Any pressure measuring device and your lungs also have a surface. A plane's wing experiences lift due to a differential pressure against a real surface. Perhaps Dave can try to be the first person to fly using an imaginary wing. He is talking nonsense. The problem is not that I have not passed middle school, but rather that the astronomers and the people who repeat their claims either never properly understood or properly applied kinetic theory. Let's move to another topic. Imagine a container of pressurized gas in a locker under vacuum. If you opened it, the gas would fill the locker evenly. Then if you open the locker in a room under vacuum, the gas would spread out evenly to fill the whole room, and so on and so forth. Now imagine starting with a lot of gas in an enormous room and releasing it into an infinite vacuum universe. What would you expect to happen? If you are a rational thinker, you might expect the gas to expand to fill the void, just like it does when it was released into an empty room. If you were an astronomer, you would say that the gas acts differently and instead of spreading out, shrinks down to form a star. In the standard solar model, this is called gravitational collapse, which can be extended to include black holes and the theoretical aspects of the Big Bang. Astronomers believe that stars are created by the gravitational collapse of a gaseous mass. This was once known as Laplace's nebular hypothesis, but today is known as a solar nebular disk model. This idea stands against the known observation that gases expand to fill the void. So how does astronomy get into this mess?
It's not getting any better here. Pierre thinks that a tiny sample of gas in a container and a gas cloud of many solar masses will behave the same way. Sorry,
Because
they
they
don't.
will.
The gravitational attraction between some gas particles in a tiny container is not only negligible in general, but also beyond negligible compared to the gravitational pull of the Earth that the container is near. A cloud of many solar masses in deep space is not the same. The gravity between the particles is the only force acting upon them, and it's a lot of gravity because it's a lot of mass. This idiotic analogy he puts forward is the equivalent of flat earthers asking to see water stick to a spinning ball. Well, a tennis ball doesn't generate the gravitational field that the Earth does, and some gas in a box doesn't generate the gravitational field that a gas cloud of many solar masses does. Some people have criticized me for comparing cranks like Pierre to flat earthers, but the more I do these debunks, the more I see how similar they are.
Yeah, but Dave, what about infinite space?
Dave insists that our knowledge of gaseous properties on Earth do not extend to stars or large gaseous masses in space. This is such a strange argument. Is there any meaning whatsoever to observations shown time and time again in our laboratories? After all, that is how the laws of physics are determined. I have emphasized that gases expand to fill empty space in every scenario. Like the astronomers, however, Dave argues that the effect of gravity brings about gravitational collapse. However, he has failed to address the thermodynamic consequences of gravitational collapse in a gas. I have already addressed the point in detail in these videos. On Earth, gases and plasmas possess what is known as positive heat capacity. The more gas or plasma one has, the more heat the total material can handle. If you can add heat to a gas, its temperature goes up, not down. However, the gaseous stars of modern astronomers invoke negative heat capacities as a result of gravitational collapse. So as the star radiates and loses heat, its temperature actually goes up. A Nobel Prize was awarded to Chandrasekhar for solving this mathematical mess, but in fact Chandrasekhar simply added a band-aid to a mortal wound. Just consider this question for a moment. How massive does a gas have to become in order for its heat capacity to change from positive to negative? Astronomers can never answer the question, and this highlights the absurdity of the gaseous models. Either way, the gravitational collapse of a gas is a violation of the laws of thermodynamics. Stars have long been considered closed systems, and such a system cannot do work upon itself, raise its own temperature, and decrease its own entropy. That is a violation of the first and second laws of thermodynamics. Furthermore, the temperature of gaseous stars is not intensive as required by the zeroth law. This causes Eddington's mass-luminosity relationship to violate laws of thermodynamics, as I explained in detail in this paper. Thermodynamics is warning astronomers that they cannot gravitationally collapse a gas because when they do so, they produce violations of known thermodynamics. The heat capacity of a gas is positive, and the astronomers cannot argue otherwise. Let's move to another topic.
Can you pause?
Dave returns to the emission spectrum.
What up,
Yo,
big dog?
that's like I mean, he's talking pretty quickly and going through this quickly, but like, that's profound to think about.
He's taking apart their entire model, and he did it well.
Yeah,
Super
I mean okay, because think about like what they're saying the star does. Instead of when you heat a gas, right? Like just think about a gas. If you heat it, it expands, right? Hot air rises naturally, right? Okay, it disperses. Cold air is denser. Hot air is more expansive. Well, as the star gets hotter, right, it gets more energy. It should expand, but there's this mass energy equivalence. So as it gets more energy or more temperature or more mass, however you want to say it, it should expand. But they're saying that actually what's happening is it's not expanding, it's shrinking, it's contracting. So they have to put a negative sign on the heat capacity equation in order to get it to go the opposite direction. But that would mean, as he said, that as it loses energy, the temperature increases, which is retarded. Like that just doesn't that is like the most simple violation of logic I've ever heard when talking about the sun.
It's just not replicable.
Did you go to star school? Where's your
Bro.
replacement for star? How can you talk about star without having replacement for star model?
Bro, like
Total human essence isn't bad.
you lose energy and your temperature goes up when we're talking about a star. That's what they're saying by giving it a negative heat capacity coefficient. That is absurd. Oh my gosh.
Listen, man, the heliocentric model is the most well-rounded scientific model that's ever been produced, and it's fully substantiated. So for you to sit here and act like these guys couldn't have figured it out with a negative coefficient where a star reduces its own entropy and heats itself up, then I think you're the problem.
Pretty much.
I don't know. I guess I have slightly more faith in humanity than I should, but it's just when it comes to
nobody knows about this. This is crazy. I've never heard anyone talk about this ever. It's like the only thing I've heard on spectroscopy is like, where's your independent variable and stuff like that. Like this is like so in depth of the historicity of it and how it came to become a field of study that's completely devoid of meaning.
I'm about to start invoking this all the time.
Dude. Okay, Pizio, hear me out. Let's come up with a series of internal processes that take place in a spot that no one could ever go. And then we can use the summation of those internal processes that may or may not be occurring to explain the physical phenomenon that we do see. What do you think about that? Like, is that like a good starting place for us?
I think we'll totally be able to pull it off. All we need to do is slide in a little bit of a negative coefficient on the thermal capacity, and just make sure that no one notices, and then it'll work just fine.
If they allow us to slide in the negative coefficient, I think we're good to go on like pretty much any explanation.
Yeah, this just never let them find out that as the star loses its energy, it gets hotter.
Yep. Classic. All right, so I think I'm ready to wrap up. Was there any other portions of that you want to check out that you remembered, Pizio? I might have some notes on it. Give me 1 second. Or some timestamps. Where was this one? Oh, dude, we had the same spot. Yeah, Pizio. We had the same spot. What's it called?
Me and you?
Yeah, I was taking notes on this and stuff and like referencing and all that, and it was same spot where you had me play back. Yeah, like that is it's pivotal to the whole thing. I'm surprised you didn't mention the ideal gas law in the paper, because that was a pretty solid argument too.
Yeah.
But, all right, I'm gonna wrap up here. Toby, you want to close us out? Do an intro? I'll beatbox. You go. Spit it.
Yo, thanks for tuning in to Ether Cosmology.
Dude, no way. No way he was gonna do it. Oh shit.
Thanks everyone for tuning in to Reading and Research Night, Spectroscopy Part 2. Tune in tomorrow night. I believe both Shane and Alan will be streaming for Flat Earth Fridays, hosted by the Levelheads. And then I do not believe we'll be doing a Bring Your Own Brenner reading on Sunday, but on Monday, Demon Stride from Medicinal Mass Media is going to host a Twitter space, and we're probably going to show up for that, and we are going to ask other people to show up for that. It's going to be a flat versus globe discussion. I believe it's open to all. And then on Tuesday, we'll be doing Ether Roundtable number 28, I believe we're on. And Shane is going to be presenting on tides, so don't miss that. And yeah, thanks again for being here, and take care, y'all.